Okay, in this question we're solving for A, and my first priority is to try and collect all the A's together. To do that, I want to get rid of the brackets, because brackets are difficult to work with. Okay, so to get rid of brackets, remember back to manipulation, you multiply the outside term by both the inside numbers. Answer 4A. What's 2 times 3? Okay, minus 6. And then 3A, and 3 times 4? 12. Okay, brackets are gone. Now I'm going to collect, there's some A's on this side and some A's on the left. A's on the left, A's on the right. I'm going to collect, I could collect them on the right, I could collect them on the left. It doesn't actually matter. I'm going to collect them on the left because there are more there to start with. Okay, so in other words, I'm going to subtract 3 from the right. And don't forget, what if I do to one side, I better do it to the other to keep it in perfect balance. The advantage of subtracting 3 from the right will cancel those ones. I'm just left with 12 on the right. And what's 4A minus 3A? Just A. Minus 6. And you can see I'm almost there. To shift that 6 to the right hand side, I would add it to both sides. The equation stays in perfect balance, and 12 plus 6 is, these 6's cancel, and I've got A equals 18. Here's another one. It's question 7b. Looks like this. 2 bracket x minus 5 equals 6 minus x. Okay, there are actually 3 groups of x's in this problem. I want to collect them all together. To do that, what would I do first? Get rid of the brackets. Expand them, right. 2 times x, 2x. 2 times minus 5, minus 10. And then everything else is still there, right? Just expanded the brackets. Let's start collecting these x's up. I've got 2 of them here, minus 1. That's just x, so 2x minus 1x is x. Are you okay if we add x to both sides to shift that x out? Right? I'm going to add x to the left, sorry, to the right, and add x to the left at the same time, because that minus x is gone. Okay, that cancels with that on the right hand side. On the right I'm just left with 6, and if we do the arithmetic, 2x plus x minus x, hey, those cancel each other as well actually. Or you can go 2 plus 1 minus 1, you end up with 2. There's still a minus 10 here. What's that, Jono?
Plus 10 each side.
Brilliant. Plus 10 on the left to undo the minus 10, plus 10 on the right. That minus 10 cancels with that. And Regan, the answer is, well done, because you divided both sides by 2. Oops, just had a power cut. Gosh, that was a very poor joke. No one laughed. Number 8. Question 8 on that same page. I'm going to get you to do up to question 10. But I'll do 8a, so you get the idea. The question reads, for each of the following examples, write an equation and solve it. A reads, 7 is added to a number and the result is multiplied by 3. If the result is 9, find the original number. So you've got to write an equation and solve it. I'll read it again. 7 is added to a number. The result is multiplied by 3. And the result is 9. You happy with this? 7 added to a number. Let's call the number, what should we call it? P. There we go. Just got that up. 7 is added to the number P. The result is multiplied by 3. And the result is 9. Is that an appropriate equation? What do I need to do? Add to it, Dylan. Speak up, please. Oh, I see. In algebra, we don't see times this. And make it 3p plus 7. We've got a problem here, guys. What's wrong? Read the question again. 7 is added to a number. That happens first. The result is multiplied by 3. Brackets. We would definitely get the wrong answer without the brackets. Now, sometimes, well, usually actually you would write it like this. 7 with a 3 in the front. Okay, those two things are the same equation. Then it says to solve the problem and solve for P, or you could call it X or A or B. I don't really mind what letter you choose. In fact, P's yeah, P's fine. What do we do first? Get rid of the brackets. 3 times 7. 3 times P. 3p equals 9. Next step. Now, take away 21 or divide by 3. Which one? You're right. I would normally do take away 21, normally, because it's the last thing that happened to P. In fact, I'll do it that way, and I'll show you. In this instance, it works both the other way as well. But take away 21 from both sides. That cancels. And we've got 3p. What's 9 minus 21? Good. And Hamish is saying that the answer is minus 4. P is equal to minus 4. Divide both sides by 3. You guys are getting the hang of this. Now, if I was to, at this stage in the problem, just write the problem out again. Watch closely. Divide both sides by 3. Right? It's legal. I mean, it's not wrong. You can, as long as you do it to both sides. In fact, you can do anything to an equation as long as you do it to both sides. If I divide the right by 3, what's 9 divided by 3? Right. Now, if I divide the left by 3, you have to do it to both terms. So 21 over 3, what would that give you? And 3p divided by 3. Most of the time, the equations, you can't, 3 wouldn't go into 21. So you'd end up with a decimal. So It doesn't work quite like this, but as long as you do the same thing to both sides of an equation, you can carry out legitimate algebra rules and get an answer. Can you see here the answer is still going to be minus 4? Because you take away 7 from both sides. So both ways we got minus 4.